Hello guys, so today we will learn how to measure the MacMullin number of battery separator. Actually the MacMullin number is very important for any kind of battery. It's used to maintain a good lithium-ion battery performance. Resistance of separator filled with the electrolyte should be low, because if the resistance is high, it's very hard for the ion to move across the electrodes. The information above is effective. Ionic conductivity of these systems is an important parameter for the performance of separator materials. So MacMullin number is a ratio of ionic conductivity of pure electrolyte versus ionic conductivity of a separator when it's soaked with the same electrolyte. So here is the simple formula. So first step is to measure the ionic conductivity of the electrolyte, which we can use this, which we can measure this using this meter inside the glow box or outside the glow box. So I have measured the ionic conductivity of electrolyte, and its value is 9.95 millisiemens per centimeter for the LiPF6 in EC and DC. Now next step is to measure the ionic conductivity of separator, but unlike my previous video today, I will use another method which is more effective to measure the ionic conductivity of separator. So the second step is ionic conductivity of separator. We will use the split cell, and this you can buy on different websites. It's made up of stainless steel, but it can open by the hand. We don't need to use the crimping machine. So top one is stainless steel current collector, which is shown by the hair, and the bottom is also stainless steel current collector. So then we have to put this ring in and insert the separator, and then close the cell with the help of this spring. So first step we will put one separator, then measure the ionic Nyquist plots. So we can measure the impedance using Nyquist plots between this frequency range using different number of separators. So for example, first we will put one separator or one specimen, and we will get the curve like this, which is Nyquist plots. X-axis shows the real resistance, y-axis shows the imaginary resistance. So then we can open it and insert another separator. Then there will be total 2 specimens. Then again measure the Nyquist plots. Then the resistance will be increased slightly here for the specimen 2. Similarly, when we keep increasing the number of separator up to maybe 5, then the resistance of the total number of separator will also increase. Then we can draw a graph between the resistance of separators. This is the resistance of separator, which is changing by number of separators or number of specimens. And we can draw a fitting line and measure the slope of the line. This slope can be used to measure the ionic conductivity if we know the thickness of separator, which is D, and area of the electrode. So once we have measured the ionic conductivity of separator, then we can measure the MacMullin number. So the next step is MacMullin number. So here I have measured the MacMullin number for the cell guard separator in LiPF6, EC and DC, and its value is 12.66. Lower MacMullin number is good for the battery. So I will also show you some raw data how I measured. So here is the Excel file. You can see this is the cell guard when I use the separator 1. When I increase the number of separator to 2, then this is the resistance. Similarly, total number of 3 separator, 4 separator, and 5 separator. And this value gives us the resistance of the separators, either it's 1, 2, or 3. Then I use these real resistance and versus number of specimens and draw a graph and calculated the slope. After calculating the slope, which is around 1.0132, then I use this formula as mentioned in the presentation. This is slope, and use the thickness of separator over area of the electrode. So the thickness of separator is around 25 micron, and area of the electrode is 20 mm. So I have converted into the centimeter, and then, for example, this is area of electrode. This is the thickness of separator in centimeter, and then I use this formula and measure the ionic conductivity of separator. So it gives the ionic conductivity 0.78 millisiemens per centimeter square, and then I use the formula like ionic conductivity of electrolyte divided by ionic conductivity of separator to get the MacMullin number, which is 12.668. So which is same here. So this is the way how to measure the ionic conductivity of the separator in a more precise way, or MacMullin number of the separators. So this is a very important test for the people who are working on the separator technology. Thank you very much.